This CFD training package includes 10 practical architectural engineering exercises using ANSYS Fluent software. This package is suggested for all architectural engineers who will learn CFD simulation in this field at every level of beginner, intermediate, or advanced. We start this training package with 4 simple practical exercises for beginner users in the external flow field. The first exercise simulates the airflow through an atrium by ANSYS Fluent software. The history of these atriums originates from the architecture of ancient Roman houses, and its modern models in recent centuries are multi-story and have a glass roof and a set of windows open immediately located after the main entrance of the building. This part of the building is used to provide the necessary light for the interior of the building as well as the ventilation process. The second project simulates the external flow of wind passing through the villa using ANSYS Fluent software. The geometry of the villa consists of several buildings and a special domain of the yard. The area around the villa is considered to be the airflow area. The third problem simulates the wind flow through several buildings in a given computational domain by ANSYS Fluent software. These buildings are considered barriers to airflow. The flow around the obstacles in the way of wind flow, such as the flow around buildings, aircraft wings, ships, propellers, rings, tall structures, and blah blah blah, has many engineering applications that one of them is architectural. Training number 4 simulates the airflow through 3 buildings which are arranged in a triangular shape by ANSYS Fluent software. These buildings are considered barriers. In the present case, the area around the 3 buildings is considered where the wind enters it horizontally at a velocity of 5 meters per second and collides with the buildings. Then we continue the training with 4 practical exercises in the field of internal flows for intermediate users, including the architectural engineering role in HVAC of various structures. Exercise number 5 simulates the internal airflow inside an atrium located in a complex by ANSYS Fluent software. Atrium works with 2 natural phenomena, including the greenhouse effect and the chimney effect. In the present case, the cylindrical area called the atrium in the central part of a complex is considered. Project number 6 is simulating the HVAC inside the room considering a solar chimney by ANSYS Fluent software. The present model consists of 2 main parts, including the interior of the room and a sloping solar chimney on the ceiling of the room. The solar chimney consists of a glass plate on its side surface that are in contact with the environment and as a transparent medium receive the solar energy and also have a plate on its back as a heat absorbing surface. In exercise number 7, the conjugate heat transfer of airflow in a simplified 4-story building model applying wind tower is investigated by ANSYS Fluent software. Turbulent airflow enters the domain from the top left region, and due to heat transfer to air from the right diagonal wall with specific temperature and heat generation rate of solar radiation, conjugated heat transfer, natural and forced convection, leads to buoyancy effect, which helps airflow to exit domain from the top right region. Then, in the 8th project, we simulate the airflow and ventilation inside a wind catcher. The wind catcher is orthogonal and has a relatively simple structure. The wind catcher consists of a column for pulling the out air to the inside or sucking up the air inside, room space for air circulation inside it, and a valve for the space around the building of this wind catcher. And also, this wind catcher set is located in a large space of open airflow computational domain. Now it's time to focus on the more advanced practical exercises for more professional users. We applied the DPM for modeling the dust particles spreading in a room. In this project, number 9, numerical simulation of dust particles entering from the windows into a room has been done using ANSYS Fluent software. The dust particles entering the building at a speed of 0.25 meter per second, and the house's sedimentation and dust movements are depicted. Also, in this simulation, a two-way DPM model is used. Finally, as the last practical exercise, we consider radiation as one of the expertise products of the CFD training package. In exercise number 10, heat transfer inside a room and a balcony is investigated by ANSYS Fluent software. The balcony has a glass roof and one glass wall. Due to the radiation of the sunlight, both room and balcony becomes warmer, and natural convection plays an important role in circulating the flow inside these spaces. By the way, you can obtain the CFD training package including 10 different practical exercises suitable for all architectures at an unbelievable price. The total cost of these 10 learning products is more than $600, which you can purchase with only 1/3 of the regular price, equal to $206. To benefit from MR-CFD services, including simulation, consultation, and training, contact our experts via www.mrcfd.com.